In this video, we're looking at factoring polynomials that are perfect square trinomials. A perfect square trinomial is a trinomial that's going to factor into the product of two binomials that are exactly the same. A lot of people teach this technique by asking the students to sort of recognize that it's a perfect square trinomial first and then jump right to the answer. I personally don't see a lot of advantage to be gained by doing that. So for me, I'm just going to tackle the problem as we would normally factor a trinomial of this type. And then from there, we'll recognize at the end we can simplify the answer a little further than normal. So let's go ahead and start with this first one by looking for a greatest common factor. There's nothing in common between x squared and 9, so I'm going to go ahead and say there's no GCF. From there, I'm going to go ahead and draw two parentheses, and I'll place the x squared in the first position of each parenthesis as x and x. Then we'll look at the sign here on the right, and we realize it's positive, so it means we're going to have two of the signs that appear on the left, which means two positive signs in the parentheses. And then I'm looking at factors of 9, so it's got 1 and 9 and 3 and 3. And we need factors of 9 that add to 6 in this case, so we're going to go for 3 and 3. We would try those pairs first, even if we're doing pure trial and error, and then we would plug them in and just check to see if that works. Well, 3x is the inside product, the outside product is 3x. If you add those together, you do indeed get 6x, and that's our middle term, so we're done with the factoring. However, it is possible for us to simplify this a little bit further than normal by basically saying that this is x plus 3 squared. And the reason why we can do that is because the two parentheses here are exactly the same. And if they're exactly the same, then we can simply write them as x plus 3 squared instead of x plus 3 times x plus 3. That's the only real difference in my opinion. This problem is a perfect square trinomial. However, ultimately the technique is really the same. Let's look at example B. If we try to find a greatest common factor here, we'll look at the 4 at the back end and say, well, that's only made up of 2's, like 2 times 2 or 4 times 1. But yet 25 only has 5's really, right? So it's 5 times 5 or 1 times 25. So there's no greatest common factor. All right, with that in mind, then we're going to try to factor it as normal with the two parenthesis approach. We'll split up the 25 as 5 and 5, x and x. Now, at this point, we'd be going on sort of trial and error. And remember, with the choices of 1 and 25 or 5 and 5, we would always try 5 and 5 first, since they're closer together than 1 and 25. And now on the back end, we have a similar issue. We have either options to choose 1 and 4 or 2 and 2. And again, we'll try 2 and 2 first. That's the classic choice. Before doing anything else, we try the closest pair. Now the 4 is a positive 4, so this plus sign indicates we'll have 2 of whatever sign is on the left. In this case, the sign on the left is negative, so we're going to have 2 negatives in the parentheses. Let's check to see if this is indeed the middle term we need. You see that it's negative 10x here, and over here is also negative 10x, and so you can tell that those add together to give you negative 20x, so we have the middle term we're looking for. And again, the last step then can be simply to write it as 5x minus 2 quantity squared. And we can do that because, again, the two binomials are the same, so we might as well write them as one binomial squared. All right, so 5x minus 2 squared is the answer. Let's look at the very last example here, example C. So again, looking for a greatest common factor, we can see that there's no GCF here, given that y squared has nothing in common with 36x squared. All right, since that's the case, we'll go ahead and put two parentheses down and try to factor it from here. For 36, let's try to split it up as 6 and 6 and x and x. And again, between the choices of 1 and 36 and 6 and 6, we would always go with 6 and 6 as the best route to split that up. The y squared is easy. That has to be y and y on the back end, right? Just y times y to give you y squared. And then, of course, the positive sign here on the right indicates we have to have 2 of the sign there on the left, which is 2 negatives again. And then we can check the middle term. It'll be negative y times 6x. That'll give you 6xy that is negative, right? And then we'll have another negative 6xy when we multiply the outside terms. And that does indeed give you negative 12xy. That's our middle term. So once again, we factored this correctly.